Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology, College of Engineering, Edra Ichalgaji, which is at District Kolhapur, Maharashtra. So, as we had gone through configurations of robots, and for that we have gone see that some configurations where joints are there, wrists are there. So, some actuations to act such kind of motions we need some drive systems. So on that basis, or what kind of drive systems are used for in robots, so we'll go through in this video. So let's get started with here joint drive systems. Here in joints, where you can see here are joints, some drive systems are used. These are electric joints, hydraulic kind of joints, and pneumatic kind of joints. Where in hydraulic the uses hydraulic pistons and rotary vane actuators, where in hydraulic noted for their high power and lift capacity is very important while using this hydraulic. And if you go through electric, so uses electric motors to actuate individual joints and performed drive system in today's robots actually. Here if you see electric actuators, among the electric actuators the step motors and the direct current motors, which constant inductor flux, or we can say they generated either by a permanent magnet or through a constant inductor current, and the controlled by the armature current are used efficiently. And the electric motor do not passes the physical strength or spread of the hydraulic unit, but their accuracy and repeatability is generally better. Less floor space is required due to the absence of the hydraulic power unit, isn't it? If you go through hydraulic, these actuators are associated with the large robots, as told, that is high capacity. If it is the high capacity, and the hydraulic system add to the floor space required by the robot. The advantages which this type of system gives to the robot is that means are mechanical simplicity, high strength, and high speed. You can their pistons are very simple and effective hydraulic system, which exists in either linear or rotary form, isn't it? In their linear version, the displacement range is generally of a few centimeters, while in the rotary version, the angular displacement is limited to about 270 degree, isn't it? So axial pistons motor provides a continuous rotation, but the technology is significantly more complicated. And come to the pneumatic drives, were typically limited to the small robots and simple material transfer applications only. If you see this pneumatic actuators, there are the linear and rotary pistons, and the pneumatic actuators are smaller and technologically less sophisticated than the other two types. The pick and place tasks and other simple high cycle rate operations are examples of that kind of this application, usually reserved from these robots. So this is a small kind of material transfer application, right? If you see next is here, the actuator is the term used for the mechanism that drives the robot arm. There are three types of main actuator, that is electric, hydraulic, and pneumatic, as we had saw. As hydraulic and pneumatic actuators are generally suited to drive prismatic joints since they produce linear motion directly. And in hydraulic and pneumatic actuators are also known as linear actuators. And electric motors are more suited to driving revolute joints as they produce rotation, isn't it? In hydraulic actuators, you can say a car makes use of this hydraulic system. If you look at the braking system of the car, we see that only moderate force applied to the brake pedal is sufficient to produce force large enough to stop that car or vehicle. The underlying principle of all hydraulic systems was first discovered by the French scientist whose name is Blaise Pascal in 1653. He started that if external pressure is applied to the confined fluid, then the pressure is transferred without loss to all surface in contact with the fluid itself, isn't it? So next, the word fluid can mean both a gas or a liquid, whether and where large forces are required, we can expect to find hydraulic devices, as we say that mechanical diggers on building sites, or we can say JCB, pits pops in coal mines, and jack for the lifting cars all uses the principle of hydraulics here. Yes, and next is here each hydraulic actuator contains some following parts. What are those? First one is pistons, spring return piston, and double acting cylinder, hydraulic transfer valve, and in some cases the hydraulic accumulators also used. What is the advantage of hydraulic actuators or hydraulic mechanism? A hydraulic device can produce an enormous range of forces without the need for gears, simply by controlling the flow of fluid. And this second one is movement of piston can be smooth and very fast even. Third one is position of the piston can be controlled precisely by a low current electrically operated valve. And last, or you can say there are no sparks to worry about as there are with the electrical motor, so the system is safe to use in explosive atmospheres such as in paint spraying or near inflammable materials, isn't it? Now come to the pneumatic actuators. A pneumatic actuators uses air instead of fluid. As hydraulic, they are using gases or fluids, liquids, fluids, and here pneumatic instead of fluid you use air. So the relation between force and area is the same as in pneumatic system compared to that hydraulic system. And we know that air is compressible, so in order to build up the pressure required to operate the piston, extra work has to be done by the pump to compress the air, isn't it? This means that pneumatic devices are less efficient. If you have ever used bicycle pump, you may have noticed that it becomes hot as it is used. You might have used before, and while in use, so many students are using this hand pump to for motorcycle tires also. So they might have gone through this experience, and that heat produced by the mechanical work done in a compressing the air, and the heat presents wasted energy, isn't it? And if you see here advantage of pneumatic actuators, Here, generally less expensive than the equivalent hydraulic system. Many factories have compressed air available, and one large compressor pump can serve several robots. This is one advantage. A small amount of air leakage is okay, but in a hydraulic system, it will require prompt attention. There should not be leakage in a hydraulic system. It's very dangerous when in a hydraulic system it won't operate properly if it is leak in hydraulic system. And the third point in the pneumatic actuator or pneumatic system, the compressibility of air can also be an advantage in some applications. uh, think about a set of automatic door which are operated pneumatically. If the person is caught in the doors, they will not be crushed. As fourth one, a pressure relief valve can be incorporated to release the pressure when a force is exceeded. For example, the gripper of the robot will incorporate a relief valve to ensure it does not damage itself or what it is gripping. Next one is the pneumatic devices are faster to respond compared to a hydraulic system as air is lighter than fluid. Here, a pneumatic system has its downfalls, and the main one is that it can produce the enormous forces a hydraulic system can. Another is the concern with the location of this piston. As air is compressibly heavy loaded or loads on the robot arm may cause the pistons to move even when all the valves on the cylinder are closed. It is for this reason the pneumatic robots are best suitable for pick and place robots, isn't it? And this is about what advantage of pneumatic system, and even we'll see last one is electric, isn't it? So now here electric motors, where not all electric motors are suited for use as actuators in robots. That is true. Yes. So there are three basic characteristics of a motor when combined will determine the suitability of a motor for a particular job. The three characteristics are power, torque, and speed. Each of these characteristics are interdependent. That means that you cannot alter one without affecting the others. This is very important. If you see here, if you see here, two types of power, that is electric and mechanical. Both are measured in the watts, isn't it? So if you see, torque is how strong a motor is or how much turning force is it is able to produce, and is measured in the Newton meters. If the speed is measured in the revolution per minute and is rotation of the motor. These are the very important aspects where we have to choose that electric motor. And there are three different types of motors even on that basis. That is AC motor, which operates by alternating current electricity, and DC motors, which operates by direct current electricity, and the third is stepper motors, which operates by pulses of electricity. And here another, you can say any type of electric motor could be used for a robot as long as it is possible to electronically control the speed and power so that it behaves the way we want, or we whatever we require it would be do. Here DC motors and stepper motors are commonly used in robotics. This is also very important to remember this thing. Now we see here robot control system, how the control system operates in a robot. Here limited sequence control, in that pick and place operations using mechanical stops to set the positions. If you say playback with the point to point control, records a work cycle as a sequence of join points, then plays back the sequence during program execution. And if you see about playback with continuous path control, that a greater memory capacity or interpolation capability to execute this path, in addition that points as well. And another is intelligent control, is nothing but the exhibits behavior that makes it seems intelligent, that is responds to the sensor input, makes decision and communicates with the humans. So automatically we can change this control, isn't it? This is what robot control system about. This is a block diagram of robot control system, where joint 1 2 3 4 5 6 etc and the sensor over here. This is what level 1 and 2, and this is level 2 where self supervisors goes. If you see here joints, it goes controller and programming, and where it would be operate with the sensors. So if both are working, so again it would be a self supervisor goes, and it gets indicates whether uh, indication can get human being, so automatically will see this and may control the system. This is what a control of system of robots. This is what flow diagram of that control system, isn't it? So next here, control methods, that is nano servo control, where implemented by setting limits or mechanical stops for each joint and sequencing the actuations of each joints to accomplish the cycle. And endpoint robots, limited sequence robot, bang bang robots, and another is no control over the motion at the intermediate points, only endpoints are known. Here in robot control system, a microprocessor based controller is commonly used today in robotics as the control system hardware. The control is organized in hierarchical structure, so that each joint has its own feedback system, and a supervisory controller coordinates the combined actuations of the joints and sequences the motion according to the sequence of the robot program. And this depending on the level of sophistication of the robot control, some controls are classified. You might have, we'll see, even though I can say that one is limited sequence control, playback robot with the point to point, this is what I'm saying, point to point control, playback robot with continuous path control, and intelligent robot control, as we have, so isn't it? So here now we'll see, and these are control system can be done in the programming accomplished by uh, setting desired sequence of moves, adjusting end stops for each axis accordingly. The sequences of moves in controlled by a sequencer, which uses feedback receivers by from the end stops to index to next step in the program. wherein low cost and easy maintain, and this is reliable, relatively high speed. We can get responsibility up to 0.01 inch, limited flexibility, right? And the typical hydraulic and pneumatic drives even for that purpose same. As I said, some control system are there. This is what servo controls, that point to point control, where point to point control, the controller has a memory for recording not only the sequence of the motions in a given work cycle, but also the location that they associated with each element of the motion cycle. And these locations and their sequences are programmed into memory and subsequently playback during the operations. In PTP control, individual positions of the robot arm can are recorded into memory, and these positions are not limited to the mechanical stops set for e-joints as in the case of limited sequence robots. And feedback control is used to during the motion of cycles to accelerate assert, ascertain that the individual joints have achieved the desired location defined in the program. And if you see in the continuous path control, the servo control is used to maintain continuous control over the position and speed of the manipulator. And a playback robot with continuous path control has the inherent capacity for PTP control as well. And in a continuous path motion, the movement of the arm and wrist is controlled during the motion, isn't it? And this is what we are talking about, the controllers. And here closed loop control used in the minority position, velocity of each joint. In point to point control, we can say that there only the endpoints are programmed. The path used to connect the endpoints are computed by the controller. That's it. And if you user can control velocity and may permit linear or piecewise linear motion only. And feedback, if you want, feedback control is used during the motion to ascertain that individual joints have achieved desired location, as I told you. Yes, the pro in often used hydraulic drives, recent trends towards the servo motor is there, and it would be loads up to 500 lb and large even. And if you see the application, where pick and place type operations can done, even pelletizing, even machine loading and unloading even can do the same. As we have told you that continuous path control, where in addition to the control over the endpoints, the path taken by the end effector can be controlled, and path is controlled by the manipulating the joints throughout the entire motions via closed loop control. And where application we can already see this, even this is a controlled path, continuous path controlled, where we are using this actuators and controllers. So this is what some we have gone through some actuators, isn't it? So next video we'll see about next topic of robots. Thank you one and all.